Okay, welcome back. I hope you still remember in the original algebra we showed before, we mentioned that in the selection, this condition we use can be very complex, right? It will be very similar for the SQL as well. We are now very complex conditions in a way across. What does this mean? And let's assume we are working on this sales table, and we plan to find the price that Joe's bar charges for the cheap beers. So what do we mean by the cheap beers? We say a beer is cheap if the selling price is less than $5, and we plan to find the price of these beers. Before we check the SQL query, you can write down this query with relational algebra first, and then you can translate to SQL. So we can write down this query in SQL like this. We select price because we want to find the price, right? And we are working on this sales table from sales. And the condition in the where clause will be like the bar equals to Joe's bar, right? Because we want to check the price in the Joe's bar, right? So we need to have a condition, the bar equals to Joe's bar, and the price is less than $5 because we want to check the price of this cheap beers, right? So the price is less than $5, denoting this beer is a cheap beer. In this way, we were able to return the price for its cheap beers sold by the Joe's bar. Right, I hope you can follow me. So we are now very complex conditions in the where clause. This one we combine two conditions via this AND. And besides this AND, we can also use some other operators to help us define some complex conditions. Generally, when we write down for this where clause, for the selections, and we can use all the attributes or the name of the attributes appearing in the relations used in the from clause. And we can use many different comparison operators like equals, not equals, less than, greater than. We can also use some like operation to change the values by times some values like times 2 as well. And we will know some like operation on strings, like the concatenation of the strings, as well as some orders of the strings. And we will know this, we will do the matching between some string versus some patterns. We can check if a string is like some pattern or not as the condition. And we will know some special stuff for comparing the dates as well as time as well in the where clause. So you can define this condition in a where clause depending on your problem or your application. And we are now very complex conditions. We also have some reminder for you because we have some details in SQL. So first of all, SQL is case insensitive. Generally, the code we write down, you can either write down them in like an uppercase or in the lowercase. It doesn't matter. However, we have one exception. If we have a string which is quartered, and then it will be case sensitive. For the other cases, they will be case insensitive. And if we plan to use a single quarter inside a string, then we may have to use two single quarters in the string to represent the single quarter. Let's assume if we have a string like this, right? And here we have to use this single quarter. If we plan to use a single quarter in a string in SQL, then we have to use two single quarters here to represent this one is a single quarter inside a string. Right, you can follow me, right? And in the condition in the where clause can use this and or not in the parentheses in the usual way, like the boolean conditions which are built. So when you write down the query in the relational algebra, you can translate the condition you write down into SQL very easily, because we are now all very complex these conditions as shown as we use in the relational algebra. Here we can show you with some more examples about this where clause. So in the where clause, we can compare the string with a pattern to see if it can match or not. So a general way to do this matching of the strings will be like, so we have the attribute name like some pattern. This attribute name denotes a string in a relation, right? Or we can use this attribute not like some pattern. So what do we mean by a pattern? Pattern is also called a string. However, in this called string, we have some special characters. The first one is 100%, this marker. We use this 100% denotes any string. And at the same time, we also use this underline denotes any charge. So for example, given the drinkers table, we have name, address, and phone number. We plan to find the drinkers with this exchange number 555. We can do so by select the name of the drinker, right, from the drinkers table, where the phone number is like 100% 555 and followed by some other phone numbers. So here this 100% denotes some strings before 555, right? And these underlines, we have 4 underlines denoting any 4 numbers. In this way, we can match this phone number with this pattern, with any numbers before 555, and we have 2 have 555 in the middle, and also followed by 4 other numbers. This defines the pattern for the phone numbers, right? With 555 as the exchange number. So this is for the where clause. Besides this, we also need to pay attention to the where clause as well, because before we assume in the where clause for all the attributes we are matching, we are comparing, they have some values. However, in the real world database systems, we know this null value, if you straight remember, right? We know some attributes to have null value. And if we plan to match or to plan to compare some attributes, and at the same time, if this attribute is null, what will happen? Normally in database systems, we use this null to represent some special cases for the attributes, and its physical meaning depending on the context. We have 2 common cases. We can use this null to denote some missing values. For example, if we know that Joe's bar has some address, but we don't know what it is missing, then we can set this address to be null. Sometimes some attributes can be inapplicable. For example, the value of the attribute spouse for an unmarried person will be null because it is not applicable for the person. Here let's think, if in the where clause and for some attributes we are comparing, we know them to be null, what will happen? If we have some attributes to be null, and we will define some boolean conditions based on these attributes, then we can assign its truth value to be unknown. We are comparing any value which is a null actually, the truth value for its expression for this condition will be unknown. Therefore, for the logic of the condition in SQL will be 3 values. Besides true, false, we also have this unknown as well. This is something we need to pay attention to when we are designing these conditions. So normally a query will produce a tuple in the answer if its value for the condition for the where clause is true. Right? When we do a select from where clause and we plan to find some matching cases for our condition, only the condition can be true, then this tuple will be valid. Otherwise, they will be illegal, right? They will be pruned. And these tuples will be generated or produced only if this condition is true. Therefore, when we have some null values for some tuples, either we have unknown as its truth value, and they will never be generated or produced in the select from where clause. I hope you can follow me, right? So for the conditions, we can have 3 different values, either true, false, and unknown. However, in the real world, we may define or design some very complex conditions. If so, how can we decide the values for the conditions? We provide you with a very simple equation we can use to decide the values, the truth values for a condition. Let's assume if we have a very complex expression for the condition, which is boolean condition, right? And we want to decide if the condition is true or false or unknown for some data tuples. So a simple way to understand how this AND, OR, or NOT work in a 3-valued logic, we can think of this true as 1 value, false as 0 value, unknown as 1/2 value. We can also think this AND as the min function or as a max function, not as a function like a 1 minus some inputs. And if we have some complex conditions which is connected by this AND or and not with some like true values, if we have an expression like this, we have true and inside it we have false or not unknown. Then the question is, what is it returning truth value? It will be very hard for you to answer this question, right? However, if we translate this expression into a function we showed above, we can get this value very easily. According to the previous example, we can set this unknown to be 1/2, right? We have not unknown, not function is not x equals to 1 minus x. Therefore, it's not unknown equals to what? Equals to 1 minus 1/2. Here we have this all false and this not unknown, right? According to the above function, we have all equals to max. Therefore, this false or not unknown equals to what? Equals to max. Inside it, we have not unknown equals to 1 minus 1/2, right? According to the previous example, we have false equals to 0. Therefore, this statement, this expression will be equal to max 0, 1 minus 1/2. And outside it, we have this AND, this operator, right? We define this AND as a min function as well. So we have min true equals to 1. So therefore, we have min 1 as well inside it, we have this expression. So we can translate this Boolean expression into an elementary algebra expression. Min 1 max 0, 1 minus 1/2. If we want to decide the truth value for this expression, we can just need to calculate the value for this elementary algebra expression in a very simple way. It equals to what? It equals to 1/2. Therefore, the truth value of this expression equals to 1/2. We know 1/2 is unknown. Therefore, we can say this Boolean expression, the result or the return value is unknown. Right? And it provides you with a very simple tool to help you decide the truth values for some complex expressions. We will translate this expression into some elementary algebra expression first by using the rule that's shown here, and we can calculate the value for this elementary expression, and we can translate this return result back, denoting the truth value for the Boolean expression. I hope you can follow me right. So this is the three-value logic. We can calculate the truth value for the conditions, which are in a very complex way.